Okay, I left off on question 22, and I'm not sure what happened, but I forgot to do 18 to 21. So let's go back and take a look at those. So 18 says the sine of 5 pi over 4. So I'm just going to look at my unit circle. 1/4, 2/4, 3/4, 4/4, 5/4. Remember, when it's fourths, it's based on a 45, 45, 90, which means both my sine and cosine are radical 2 over 2. The sine is the y value, and because I'm going down, it's negative. Number 19 says the cosine of 210 degrees. Well, I know 180 degrees is here, and I want to go 30 more degrees. So if you can see, this triangle is based on this one over here. So again, this is my longer length, which this is radical 3 over 2, and this is 1/2. So same thing, radical 3 over 2, this is 1/2. And we're looking for the cosine, which is the x, and because we're going left, we know it's negative. All right, moving on to the next one. Number 20 wants the tangent of negative pi over 4. So that means I'm going here. Your x and your y value are both the same. They're radical 2 over 2, but your y is negative. So we have negative radical 2 over 2 divided by radical 2 over 2. And because that's the same value, we end up with a negative 1. Finally, the last set in there is 9 pi over 2. So 9/2 pi radian would be equal to 4.5. So that's 2 radians, 4 radians, and 1/2 of 1. Puts me right here, and I'm looking for the cosine, which is my x value, which in this case would be 0. Okay, then I did 22. We're going to go on from there. We're going on to number 23. They want us to find the coordinates, similar to what we were doing. So let me get a new piece of paper. So 23, we are looking for the coordinates at 5 pi. So again, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. The coordinates right there are negative 1, 0. 24, they want us to go 2/5 of a revolution. So I'm going to go ahead and convert that to degrees. So that goes in there. 72 times, we end up at 144 degrees, and actually that's not based on either special right triangle, so at this point we can't do it with a calculator, so we're going to skip that. Let's move on to 25. We're looking for when the cosine is negative 1/2. So let's think about your unit circle. That means you're going out 1/2, and you could be up here or you could be down here. So that means we're somewhere over in here. And it looks like they want exact values. So this one right here, this is 1/2, and this is radical 3 over 2. That means this is a this is a 60-degree angle. So it looks like I'm counting by 30 degrees. So there would be 30, 60, 90, 120 degrees. If I counted in 6, 1, 6, 2, 6, 3, 6, 4, 6. So I have 4, 6 pi. Or I could go down here. So that's 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, and 8, 6 eventually reduces to, actually both of these can reduce, that's 2/3 pi, and that's 4/3 pi. Okay, now we're going to start skipping around. Okay, moving on. Now we are jumping to question number 31. For which values of theta is the sine negative, which is less than 0, and the cosine of positive? So we're looking for this to be positive positive, negative, which means we're down in here. We're given in radians. This value right here is 3 pi over 2, and this is 2 pi, and that corresponds with letter. Next, we're going to skip to 34. Okay, they give me the sine of theta is equal to k. So, unfortunately, they're kind of sticking it to us in two different ways. First of all, they don't give us the angle measure, and they give us our y value actually in terms of a variable. So let's go over here. And like I said, we don't know where it is, but we at least know that this value is k, which is your y. We know this is 1, and we can actually go find the x value using Pythagorean's theorem. So x squared plus k squared is equal to 1 squared. We're going to solve this. And eventually we're going to go and take the square root. Now we can't simplify what's underneath. So x could be positive, the square root of 1 minus k squared, or x could be negative, the square root of 1 minus k squared, just depending where we're at. So I'm going to skip 34 for just a second. We'll come back to it because that one they're really kind of out to get us. So in 35, they want us to go pi So we're supposed to go to pi, no, we're supposed to go to theta, and then we're supposed to go back pi, which would put us right here. So if you can visualize, here's the triangle. I still have the same x value, I have the same y, but notice that y is negative, and we want y because they're asking for the sine. So this distance is k, because I'm going down, we know it's negative k. Let's go to 37. 37 says I'm going to theta, and then I'm adding pi, so that means I actually end up here, but in this case they want the cosine, which is this length right here. Notice it's negative because you're going to the left, and it's the negative of that square root. Alright, let's go back up and see if we can tackle 35. So 35 says we want to go to pi over 2, and then we want to go backwards that same amount. So if you can visualize, we're going to end up with our triangle looking like this. So notice the lengths are the same, but the x and y coordinates have flipped. So in 35, we're looking for the sine. That means we're looking for this value, which corresponds with this value here, which was the 1 minus k squared, and we're taking this one. Last set of those. I think this was actually 35. 37. Right. I did go and do 37. Finally, let's go back and do 35. Okay, 35 says we're supposed to go all the way over here, and we're supposed to go back this degree measure. So that puts our triangle here. We're looking for the cosine, which corresponds with this value here. And again, it's negative because we're moving to the left. Square root of 1 minus k squared. Okay, moving on to 38. We're looking for when is the cosine Alright, and 38, they want to know if we have the cosine of theta plus 5 pi, is that equal to the cosine of theta? So let's take a look at the unit circle. Again, I don't have a degree measure. That's okay. Let's just start here. Let's suppose that value there is radical 3 over 2. So if I go around 5 pi, that's 2 pi, 4 pi, and 5 pi. Is this coordinate here the same as that coordinate there? And that is not true, or it's not always true. So question 38, I think all they want is true or false. Let's go to 39. Now they're asking for that in terms of the sine. So let's use the same picture. If I start here and I go around 2 pi, 4 pi, I'm always going to end up right back to where I started, which means the sine is not going to change at all. said sine squared plus cosine squared is equal to 1. And the last one, number 41. So let's go and visualize where I might be. It says my cosine is negative 1/4. So this would be negative 1/2, negative 1/4 is here, which means I could end up here on the unit circle, or down here on the unit circle. So again, we know this distance is negative 1/4. I don't know that, so let's go use Pythagorean theorem. Negative 1/4 squared plus y squared is equal to 1 squared. That's 1/16. I'm going to rewrite that 1 as 16 over 16. We get y squared equals 15 over 16. Finally, we go and take the square root. We end up with plus or minus radical 15 over 4. And that's for the values of the sine. Now for b, they want the tangent. So remember, here was our sine, up here was our cosine. So we have plus or minus radical 15 over 4 divided by a negative 4. So first of all, the 4's can cancel. I have positive divided by a negative, that would be a negative. But you also have the case of negative divided by a negative. So we end up with plus or minus radical